Bismillah ar-Rahman ar-Rahim. Last time, Shabab, we were talking about we took a few examples. We talked about the processes, different processes, and then we took an example for a constant volume process. And then we started talking about the internal energy and enthalpy. And we said the specific internal energy and the specific enthalpy is very similar to other properties. So they are properties, they are tabulated. All different phases and states also have corresponding internal energy and enthalpy at specific temperature and pressure. Okay, so and we said H also is defined as U plus PV, and then all the three tables have, as I said, tabulated U and H. You have UF, UG, HF, HG, etc. Okay, and then you can use these equations, UF plus X, UG minus UF, etc. for the saturated mixture property. Okay. Today, Shabab, we'll talk about additional properties. Maybe you have seen it before, okay? Which is called the specific heat or the heat capacity. تتذكرون شباب الهيت capacity? Do you know what's the heat capacity?
Yes.
من اللي
علي الرجال. It's the amount of heat the matter can absorb. Or yes.
Okay. What else? Who else can maybe say something about it?
The heat capacity, Doctor.
Mm-hmm.
It
Yes.
is the energy required for every 1 kilogram to raise it for 1 Celsius.
Okay. It's actually 1 gram, I think, not kilogram. But this is correct. So it's the amount of heat required to raise 1 gram of substance 1 degree Celsius. But how can we think about this physically? Okay. So the other way you can think about the heat capacity, ya Shabab, one of you maybe mentioned that, is the ability of the substance to absorb heat or release heat. Okay. So, for example, if I have, let's say, water here, okay, versus, let's say, oil, okay, this is just an example. Assume, and for example, the water has higher heat capacity. So the water has ability to absorb the heat and keep the heat, okay, for some time. The oil is the same. If the water absorb the heat and keep it longer time, or doesn't easily release the heat or dissipate the heat, this means that it has higher probably heat capacity. Okay, compared to the oil, for example, if it absorbs the heat quickly and then release the heat quickly, this is has lower capability to do that. So that means it has lower heat capacity. Okay, so this is, you can think of this heat capacity physically in this sense. In thermodynamics, in our course, Shabab, we define the specific heat in terms of the properties of the substance. Okay, so what is the definition of this specific heat? There are two types of specific heats in the first place. The first one is measured or determined, the specific heat determined at a constant, ايش يا شباب? At a constant volume. So when they keep the matter or substance in a constant volume, and then they try to measure or calculate the specific heat. And then they found that the relationship for the specific heat with the other properties is the following. They found that the CV equals partial U by partial T at constant volume. What does that mean? وش يعني partial يا شباب؟ البارشل وش هو؟
Just
derivative.
It's derivative, but that means my U here, which is the internal energy, is a function of what? Function of more than one variable. Function maybe of temperature, function of pressure, okay? Right? So if you want to take a derivative with respect to one of the independent variables, if it is more than one independent variable, we take the partial derivative. Okay, so this is exactly the same. Since the internal energy is a function of more than one variable, so we take the partial here. So they found that the CV is the partial derivative of the internal energy with respect to the temperature. Okay, so this is for the constant volume specific heat. What about the constant pressure specific heat? That's the other type of, or other type of, or way to measure specific heat, is measured at constant pressure, and we call it CP. CP was found to be partial H, or enthalpy in this case. So the derivative of the enthalpy with respect to the pressure at a constant, with respect, sorry, to the temperature at a constant pressure. Okay, so again, CV is partial U by partial T at constant volume. CP is partial H by partial T at constant pressure. Okay, so these are the two definitions of the specific heat. And since the specific heat is a function of properties, it means it's also a property. So the specific heat is also a property of the substance. So that means it is also, can be also a function of CV, is also a function of temperature, function of pressure, etc. The same thing with CP, is a function of temperature, pressure, specific volume, etc. Okay? أي سؤال على السبيسيفيك heat يا شباب؟ Any question about specific heat?
We will study the specific heat for all matters or just specific matters like water and refrigerator and such things.
احنا بنتكلم عن ايش؟ يعتمد whatever the tables give you. الحين في tables في tables that tabulate the specific heat for different matters, different substances. It has corresponding specific heat. So whatever the tables available in the tables, you might see it يعني, in the question or the problem. Okay, but you need to understand the basic حق the specific heat and how it is defined. Okay. For example, in some of the analysis, let's say, we'll talk about it in a minute, but one of the analysis, for example, requires you to calculate delta U. So from this definition of the CV, I can calculate delta U by using CV. So we will look into that in a minute. Okay. لكن to answer your question, whatever tables available in the thermodynamic tables, that's also included here. Like the basic idea is that CV and CP are properties, okay, and they depend on, يعني, you can find them based on at different temperature and pressures, okay.
دكتور
Yes.
بس معليش أنا ما فهمت سالفة الكونستنت فوليوم وكونستنت تمبريتشر.
طيب، الهيت كاباسيتي زي ما قلت لك هي تتغير. يعني كيف اقول لك؟ تذكر يوم تكلمنا عن موضوع independent properties، يوم قلنا انه we can fix one property and change the other، صح؟ Do you remember this one? If I'm able to, for example, stay at one pressure and then change the temperature of the substance, and then we measure, for example, other properties at that, right? تذكرها ولا لا؟ We talked about it. So this is something similar. We can measure the specific heat. We fix one variable. In this case, we fix the volume. Okay, we fix the volume and then vary a temperature, let's say an internal energy in this case. And then based on this, I can calculate the specific heat. Or this is how we can define the specific heat in this case. The other type is that no, we fix the pressure in this case. So we keep the pressure constant and see what is the relationship between the enthalpy and the temperature. And this gives us basically this gives us the specific heat, Cp. Okay, so it is by definition, yani you can think about it, it's by definition, but also using this independent concept, independent property. Did I answer your question? Is it better now?
Yes, يعطيك العافية.
Allah. Okay, any other question? Any other question here? طيب, there is also another property which we call K. K هذا ايش يا شباب? We call it specific heat ratio. Specific heat ratio عبارة بكل بساطة عن Cp over Cv. يعني when you divide the specific heat at constant pressure, if you divide it by the specific heat at constant volume, you'll get what we call the specific heat ratio, or K. Okay? So why do we use this K? Because sometimes it's easier in the analysis, and يعني it makes our analysis sometimes easier. Okay? So that's why we call this, we have this property K. So this is one more information for you, which is the specific heat ratio. Let's see. Any questions so far before we move to the next point?
Victor, you're right. FBT is equal to FBT in the CV, and it's the same in the CB.
F وين كاتب هنا؟
على اليسار، على اليسار specific heat ratio.
هذه قصدك؟
إيه.
Yes, so احنا وش قلنا؟ انه based on two independent properties I can find any property, صح؟ So the CV, as I said here when I was talking about this, since U is a function of also any two independent properties, I can rewrite CV and CP as a function of any of two of these independent properties. So it is a function of pressure or temperature, maybe temperature and specific volume, maybe pressure and specific volume. Okay, so any two independent properties, I can find the third property. Okay, so that's why I write it like this: function of pressure and temperature, or specific volume and temperature. So based on any of these two independent properties, I can find the specific. Any other question? More questions? Okay, it's good. طيب next يا شباب، احنا الى الان يا شباب وش سوينا؟ بس عشان quick summary، احنا we tried to evaluate properties from tables. قلنا عندنا 5 different states and 3 different tables: saturated mixture table, compressed liquid table, and superheated vapor table. Okay, if you look at, so these 3 tables we saw them for water. If you look at other substances يا شباب, if you look at other substances, for example, if you look at the refrigerant 134A, you will see that we have saturated mixture table and superheated vapor table only. We don't have the compressed liquid table. طيب لو جاني سؤال يا شباب، ممكن الظاهر الهومورك في سؤال زي كذا، لو جاني سؤال the state is compressed liquid لكن ما عندي compressed liquid table, what can I do? Okay, there is a way to approximate the liquid properties, okay, from the existing already tables, specifically saturated mixture table. There is a way to approximate this. I will talk about it. The other thing يا شباب, if I have a liquid or solid and it goes through a process, and if this, for example, process does not affect the specific volume or density, خلينا نتكلم عن density. If it doesn't affect the density stays constant, this gives us a way to approximate and simplify our substance. Okay, so we can make some assumptions or approximations to say that, oh, since the density is not changing during this process, that means maybe my properties are not dependent on one variable, maybe it depends on some other variable only. Okay, we'll talk about it. So these are يا شباب ways to approximate properties for liquid and solid, and this is what we're going to talk about today. So we're going to talk mainly about two approximations. As I said, for liquids, we'll approximate properties for liquids if they don't have data. The other way is to approximate liquids and solids if we have constant specific volume or constant density. And this approximation is called, maybe as written here, the incompressible substance model. Okay? Incompressible يعني ايش؟ يعني غير قابل للضغط. يعني كأننا نقول انه our density or our specific volume is not changing. Okay, so the pressure is not high enough that it can lead to change in specific volume or pressure. Or density. So we can approximate the substance by incompressible substance. ايش الريزلت حقها يا شباب؟ We'll talk about it later. The result it will only depend on the properties will only depend on temperature. Okay? So let us start with the first approximation for liquids. As I said, we can approximate liquid properties using what? Using the saturated liquid properties. Okay? Let me actually start a new sheet just for clarity. Okay. So I'm gonna plot here. Let's say this is my TV diagram. Okay. This is my dome. Let's say this is my dome. Let me plot the constant pressure line like this. All right. Okay. So let us say شباب assume تخيل انه جيت اعطيتك سؤال وقلت لك this temperature is T1 and this pressure is P1. Okay. Let's say this is my P1 here and this is my T1. So you check the tables, you found that this is a compressed liquid state. This is at a compressed liquid state. طيب تجي تطالع ما عندك compressed liquid table. ما عندك compressed liquid table. What can you do? If you look at this يا شباب, usually when we look at the compressed liquid properties like this, when we have this pressure table, you will see that يا شباب, the F state here, which is the saturated liquid point, is very close to this line, اللي هو constant pressure line. Okay? So this is my VF now, and this is my actual V. This is the actual V اللي فيها البوينت حقتك الداتا بوينت. لكن ما عندك ايش؟ ما عندك التيبل حقت الكمبريس ليكويد فور ذس سبستانس. طيب وش تسوي؟ انت تيجي تطالع تقول اوه الاف والله قريبه هنا، يعني this one here is very close. So my specific volume, the actual specific volume in terms of temperature and pressure, right, as a function of temperature and pressure, is very close, is approximated by my VF here. So this one here is close to VF at the given temperature, which is T1 in this case. Okay, so it's approximated if you take this temperature T1 and you take the F value here, the property at the F state or the saturated liquid state, this will be a good approximation for the actual liquid properties. ركزوا يا شباب, you need to take a saturated liquid data at the given temperature. ما هو البريشر at the given temperature, لأنك لو غيرت البريشر كذا, you take different pressure, the value might be different than what you need. So you take the same value as the temperature. Okay. طيب هذا كلام صحيح ولا أنت قاعد تصرف علينا؟ كيف نقدر نتأكد؟ Let's take, for example, let's look at the tables to make sure that what am I saying is right or wrong. So let's go to the tables. Let me share with you the tables here.
دكتور
Yes.
معليش بس عندي بس سؤال على الآن إذا هذا إذا البريشر عندي كونستنت طب اذا
لا
صار
لا
عندي
مو شرط
temperature
مو شرط. انا اتكلم، انت عندك، انا اعطيتك temperature وبريشر، الستيت حقتها طلعت liquid compressed liquid، تقدر تروح saturated mixture table at that temperature، مو البريشر، at that temperature and you take the saturated liquid that it will be close to the point that you found, that originally close to the actual compressed liquid that مو عند اوريك الحين. خليني اتكلم في التيبل وبتفهم نقطتي. تعالوا نشوف هنا الكمبريس ليكويد داتا. تخيل انه عندك طلع انه البريشر، انا اعطيتك بريشر 25 بار و80 ديجريز، حلو، واضح؟ اعطيتك البريشر 25 بار و80 ديجريز وقلت لك اوجد السبيسيفيك فوليوم. تخيل انه ما عندك الا التيبل هذا، كم السبيسيفيك فوليوم هنا في الكمبريس ليكويد؟ ها شباب 1 بوينت، تشوفون
1.028
1.028 times 10 to minus 3 متر كيوب per كيلوغرام. ممتاز. طيب افرض انه ما عندي تيبل هذا، فكيف اسوي approximation؟ انا عرفت انه based on this temperature and pressure this is a compressed liquid state. However, I don't have compressed liquid table, so I can go to the saturated mixture table. Don't go to the pressure table, go to the temperature table and go to 80 degrees Celsius. كم ال specific volume؟ 1.029 which is very close to 1.028. مو بس يا شباب specific volume، تخيلوا اليو هنا، اليو كم؟ اليو 334.86 كيلو جول في الكيلوغرام at 80 degrees Celsius. خلونا نروح الكمبريس ليكويد نرجع له. هذا الكمبريس ليكويد كم اليو؟ 334.29. هذه كانت 0.86، هذا 29. You see it's very close. خلونا يا شباب نغير البريشر but let's keep looking at 80 degrees Celsius. Let's go to 75 bar at 80 degrees. كم اليو؟ 333.15 which is still very close to 334. You get the point يا شباب. Even if I have multiple pressures at the compressed liquid table, however, the temperature at the same temperature data are very close to the saturated liquid. Okay, the data or the properties are comparable to the saturated liquid property. So that's why if I want to approximate compressed liquid data, I can go to the saturated liquid data at the same given temperature and take the property. وضحت يا من لسان الوليد اتوقع ولا؟
وضحت دكتور، بس معليش، طب والبريشر؟ يعني لو شفنا
ايش في
البريشر
البريشر؟
هذا،
ايش في البريشر؟
يعني فرض يا دكتور انت اعطيتني 25 بار، لو رحت عند التيبل حق البريشر ما راح يطلع نفسه؟
لا، خلنا نروح عند البريشر تيبل، خلنا نروح 25 بار عشان تفهم ليش انا قلت لك البريشر از نوت رايت. الحين هذا البريشر تيبل، نروح عند 25 بار. كم اليو؟ كم شوف اليو 95، شوف الفي 1.1. الفكرة مو في البريشر، قلت لك if I come back here, this is constant pressure line, this is pressure 1 is constant, and I'm comparing ايش؟ this interval is closed for the temperature only. يعني this is closed, data are closed for the same temperature at the given فهمت علي؟ at the given temperature the data are comparable. لما تتكلم عن pressure ثاني انت تتكلم عن ايش؟ انت تتكلم عن هنا let's say P2 is a different pressure, totally different pressure. حلو؟ فالتوتالي different pressure، فانك انت كانك compare ايش؟ compare خلينا نقول let's see how can we, yes, for example this point, connect, compare this point with this point. okay, which is far. يعني it's far, it's not close. So we're talking about here يعني ال approximation حقنا ليش؟ لأنه ال constant pressure line is very close to the saturated liquid line. That's the idea. Okay, that's why when you cross
okay.
here, yeah, when you pick the same temperature, these 2 points are close. That's why it's approximation at only the temperature, not the pressure.
يعطيك العافية دكتور.
الله يعلمك. أي سؤال ثاني؟ وضحت هنا؟
طيب يا دكتور،
Yes.
إذا كان مثلا at constant temperature وكان بين مثلا قيمة موجودة at 25 بار وقيمة موجودة at 75 بار،
اوكي.
كيف بطلع البريشر حقه؟
دقيقة، سؤالك له علاقة بالابروكسيميشن ولا ما له علاقة؟ تتكلم عن الابروكسيميشن، تتكلم عن عندي نقطة وبسوي لها انتربوليشن يعني. احنا نتكلم الابروكسيميشن هذا، نتكلم انه ما عندك الكمبريست ليكويد تيبل، يعني التيبل اللي وريتك اياه هذا ما هو موجود، مو عندي. يعني خلينا نرجع هنا اوريك مثال. لو تروح هذا شوف الريفريجرنت 134A، عندي بس saturated mixture temperature table pressure table، عندي superheated فقط، ما عندي compressed refrigerant. فلو عندك داتا اعطيتك temperature وبريشر حقت refrigerant وطلع لكم انه compressed liquid، فما يهمني وش البريشر، خلاص اروح عند الساتوريتد ميكتشر تيبل عند التمبريتشر واخذ البروبرتيز واقول انه هذه its approximation for that liquid. ما ادري انا سؤالك ولا شيء ثاني؟
لا شكلي أجل كنت ما أدري، أفكر كنت تتكلم عن الانتربوليشن صح؟
لا انا الحين ليش رحت للووتر؟ لان الووتر فيه compressed liquid واقدر ابين لك اثبت لك انه الفاليو سمول كلوز سيميلر، فهمت؟ لكن احنا بنستخدم الطريقة هذه فقط لما ما يكون عندنا compressed liquid table.
طيب
دكتور
وضحت؟
ما
وضحت إيه؟ تمام يا دكتور.
دكتور معليش، بس الدايجرام اللي انت ارسلته قبل شوي لو ترجع له، انا لاحظت برضو من قبل انه حتى اللي تحت يبدا يبتعد شوي، فلو فرضنا ان التمبريتشر از لو.
شوف هو في رينج معين you might start deviating from the value. اوكي، يعني في رينج معين للتمبريتشر يكون الفاليوز تبدا تصير اكبر. فيو ار رايت انه ممكن at a specific range، بس you need to define this range and يعني this is outside of the scope، يعني this is not what we are talking about. For now you can approximate any liquid with the saturated liquid, but at certain points, maybe at certain temperature range, okay, you might have actually a little bit further points. And we can try to experiment ourselves now. Let's go to the water table and experiment. Let's go to low temperatures. Okay. خلينا نشوف. هذا refrigerant. Let's go to low temperatures and check. هذا superheated. Okay. طيب هنا خلينا نقول هذا temperature table. Okay. Let's take the lowest point here, for example. I don't know if that's available in the compressed liquid. خلينا نروح compressed liquid to check what's the lowest point there. It's overheated. This is compressed liquid water. The minimum here was 20 degrees. Okay. So 20 degrees is 1.000. And let's say LU is 83. So let's go to saturated mixture table, temperature table. Let's go to 20 degrees. 20 degrees here, 1.00, and this is 83. It's still close, still close. Yani we're still in the approximation limit or range. Okay, maybe if you go lower temperatures, maybe you have more deviation, maybe. لكن for now it's still a good approximation.
جميل.
Okay. Any other question? طيب فبالتالي يا شباب يعني one thing to notice here. So my specific volume can be approximated like this. The internal energy U, as we saw, as a function of temperature and pressure, can be approximated also by the UF at that temperature. ال H يا شباب a little bit different. ال H can be approximated as ايش؟ ال H عبارة عن ايش؟ عبارة عن U صح؟ plus PV. مظبوط؟ طيب ال U can be approximated as UF TMP plus pressure times ال V can be approximated as VF at that temperature. Sorry, هنا غلط أنا غلط. This is UF at the temperature only plus P times VF. طيب what can I do? How can I rewrite it in terms of HF يا شباب أو لا? How can I write it in terms of HF? عندك ال HF equals UF plus P saturation, this is saturation state, times VF. Okay, so UF I can rewrite it as HF minus P saturation times VF. Okay, so if you take this one ya shabab now and you put it here, you end up with eventually HF as a function of temperature only plus VF P minus P saturation. فبالتالي يا شباب هنا ال H as a function of temperature and pressure is not approximated only HF, but there is additional term here. Okay, there is additional term here. However, if the pressure I have, if the given pressure is close to the saturation pressure, or خلينا نقول لك if this term is small. If this term is small, I can neglect this one and then end up with H equal approximated as HF. Okay, لكن لازم تفهمون انه ال H مو على طول approximated as HF. It is approximated as HF plus some certain term. If this term is small, then I can approximate it as HF. If it is not small, يعني لو كان في فرق كبير بين saturation pressure at this temperature, at the given temperature, وبين ال given pressure, then you cannot neglect this. Okay, يعني خلينا نقول له طلع هنا عندي هذه 100 زائد 2، خلاص اقدر اقول 100 زائد 2 100. لكن لو مثلا 100 زائد 50، لا 50 is significant, so I will add it. So this is how you can approximate the property for the enthalpy for the liquid. وضحت هذه؟ Is it clear? أي سؤال يا شباب؟ Any question here? This is what I wrote here. This is what I wrote. Okay. طيب, excellent. So this is the first approximation for liquids. We can approximate liquids with the saturated liquid properties at the given temperature. For the other approximation, as I said, if we have a specific volume or density is constant, if the density is constant during a process, I can approximate this substance to be incompressible substance. وش النتيجة حقت هذه؟ النتيجة انه ال property now is not a function of temperature and pressure, it's a function of temperature only. Okay, so we will assume that the pressure doesn't affect much the properties, and the properties will only depend on the temperature, will only depend on the temperature. This is what we call the incompressible substance model. Okay, يعني لما تسمعون ب incompressible model على طول automatically in your mind the density or specific volume is constant, okay, and the properties are a function of temperature. This is the two things that immediately you should understand when you hear the word incompressible substance. Okay, فبالتالي يا شباب, yes, go ahead.
معليش بس يعني incompressible substance يعني انه في الجراف هو يمشي vertically up or down. If it is
يعني يصير كأن الفوليوم أو الدنسيتي is always يعني the process is always vertical يعني تكون. Okay, يعني the specific volume is constant, the density is constant. Okay.
right.
So طيب الحين فهمنا ايش يعني incompressible substance. طيب وش النتيجة حقتها على ال other properties؟ مثلا خلينا نقول السي في، تتذكرون السي في والسي بي؟ تكلمنا انه السي في والسي بي السي في is the partial U by partial T, السي بي is partial H by partial T. Can we do it for incompressible model? It will be a little bit different. ليش؟ لأنه ال properties now are a function of temperature only. فبالتالي ما عاد هي partial anymore. It's gonna be du by dt. So CV will be du by dt. Why? Because it's only a function of temperature. That's why I write it now as du by dt. طيب, what about the CP? السي بي احنا زي ما شفنا اول انه السي بي is defined as dH by dt. طب خلينا ناخذ الديفينيشن حق ال H اللي هو ايش؟ H equal U plus PV. Let's take this definition. Let us take this definition and put it here instead of let's put it in this derivative and take the derivative. So it's gonna be d by dt for U plus PV. ال PV هذه يا شباب وش هي؟ احنا ايش اتفقنا؟ انه ال V is constant now. The specific volume is constant and I don't have the temperature. Okay, I have PV, so this term is basically a what? This term is constant. So the derivative eventually becomes du by dt plus what's the derivative of the constant?
Zero.
صح? Zero. So we end up with what? We end up with du by dt similar to the CV. So CP becomes CV for incompressible model. So for incompressible substance, CV equal to CP. And this applies for the case of what? Incompressible substance. This we applied, this approximation is only for liquids and solids. Liquids and solids. So you cannot apply this for gases. We'll talk about gases later. أي سؤال هنا? Any question? If you feel I'm going fast, please tell me. يعني لأنه في a lot of material, we are a little bit behind. يعني I'm trying to catch up. يعني. Okay. فاحنا وش اللي قلنا so far انه for incompressible substance my density or specific volume is constant and the properties are a function of temperature only. For the result for that is that the specific heats for liquid and solid, if they are incompressible substance, are equal. So Cp equals Cv let's give it the name C. Consider it C. Okay? And then incompressible substance, this applies for liquids and solids only. Alright? So if we want now to as I said يا شباب أول أذكركم قلت لكم إنه sometimes we can use the specific heat to evaluate the internal energy. How can we do that? We can rewrite the internal energy du equals C dt. يعني حط هذه بس جبت dt هنا وتصير du equals C dt. You can integrate from state 1 to state 2 for example, and then you end up with this equation. Delta U or U2 minus U1 equals integral from T1 to T2 of C dt. And C here, as I said, for incompressible is a function of temperature only. So this is what we're talking about now, incompressible substance. We're still talking about incompressible. So delta U equal integral of C dt. طيب, what if C is constant? Sometimes the C also doesn't change with temperature. Okay? So C, sometimes the specific heat can be approximated as constant during the process. In this case, we can خلاص يعني we take the C out as a constant and then integrate. We end up with delta U equals C delta T.
Doctor, how
Yes.
the specific heat doesn't change with temperature?
It depends on the condition. It depends on the condition. Sometimes, yeah.
السبيسيفيك هي درجة الحرارة المادة تتغير على حسب الكيلوغرام على حسب الجرام.
It depends on the mass, it depends on the volume of the substance, it depends on the pressure and temperature. So at certain conditions, I can see that my C or specific heat is not changing much with the temperature, for example. So I can take it as constant. Okay? At, let's say, another temperature range, let's say very high temperatures, the C changes very much. So I cannot take it as, for example, constant. So it depends on the temperature range and the conditions. يعني.
دكتور
Yes.
الآن تقول اللي هو السي كونستنت بس السي فانكشن اوف تي. السي function of t, right?
Yes.
So if it's constant يعني بناخذ أمثلة يا دكتور على هذا.
في أمثلة إن شاء الله يعني بتاخذون فيه في الهوموركس when you take the homework. Remember زي ما قلت لك يعني مثلا السي المشكلة ما عندي يعني exactly the trend of the sea. If you Google it, see the specific heat, for example, with temperature for water, for example, you might see, I'm not sure, but you might see at a certain range, and والله C is like this, then maybe increases like this. فهمت قصدي؟ فممكن at specific range you can consider the C constant. فهمت الفكرة؟ In some example, in some problems, we tell you that take C at the average temperature, but take it constant at average temperature. فممكن تقول T1 plus T2 over 2 وتاخذ C at this average temperature to keep it constant for simplicity يعني for the simplicity of the analysis. Okay? Remember يا شباب, we always try to approximate in engineering and in science. We always try to simplify problems by making assumptions. لما نقول C is constant مو معناته this is accuracy 100%. لا, this is an approximation. Maybe the actual changes لكن the change is not much, so I can consider it constant. نفس الشيء incompressible model. It's the same idea. Okay? This is the idea here. The same thing can be applied يا شباب to enthalpy. So I can write enthalpy delta H equal delta U plus V delta P based on U plus PV for each state. And then I can rewrite U here. Okay. وش تلاحظون يا شباب انه اليو الدلتا U equal C delta T. الدلتا H ايش يساوي؟ C delta T plus V delta P. If this term is small, we also end up with delta U equal delta H. And delta H will be the same, C delta T. Okay? So again, it depends on the. This is just يا شباب to show you. If you remember, we talked about tables, we talked about figures, we talked about equations. These equations, some of the equations we use to approximate properties. Okay. In this case, يا شباب, we use for liquid and solid, we use the specific heat to approximate the properties. Okay, as an equation. So we can approximate properties for internal energy, for a specific enthalpy, using the specific heat and temperature in this case. Okay, وضحت الفكرة يا شباب. So what are we trying to do? We always try to approximate or evaluate properties. That's what we're trying to do using different methods. Any question about the specific heat in compressible model?
طب دكتور
Yes.
الآن يعني احنا شلون بنستفيد فرضا وش الحالات اللي والله بنحتاج والله هذا الكلام؟
انت انسان مستعجل. احنا بنروح هذه كلها بنستخدمها في الفيرست لو thermodynamics, السكند لو thermodynamics. لكن for now we are learning how to evaluate the properties. What does it mean?
طيب
Are properties. لكن use of this properties, you are right. يعني I agree with you. We are gonna do and apply these in application. يعني we will go and try to apply it in actual cases in some analysis. لكن where is this analysis? This is gonna be later. يعني when we talk about the first law of thermodynamics, the second law of thermodynamics, you will see all of these. Okay. That's the idea. يعني you will need delta H, you will need delta U in the equation for the first law, second law. You will apply it using this method. فهمت علي بديت؟
فهمت عليك يا دكتور.
أي سؤال يا شباب؟
ايوه يا دكتور بس معلش في الانك
معلش اللي ما عنده سؤال بدي يخرج.
خلاص احنا خلصنا يعني ما عاد في شيء، بس اللي عنده سؤال يسأل ولا خلاص يعني there's nothing. You're free to.
اسالك يا دكتور.
ايه go ahead.
الانكمبريسبل موديل البريشر ايش وضعه؟
قلت لك البريشر يعني البريشر موجود، يعني في بريشر ويمكن يتغير عادي، لكن تأثير البريشر على البروبرتي يكون قليل. هنا الفكرة. فهمت؟ البريشر كأنه ما يأثر على البروبرتيز تأثير قوي. فلو تغير البريشر whatever the pressure value is, I assume that the property will change only with temperature, not with the pressure. لكن هنا زي ما شفت في الاناليسيس، لو ترجع هنا لو تلاحظ عندي هنا I use هنا P1, I use P2, so I use the pressure, but in terms of effect على the properties I care more about the temperature. فهمت علي؟
تمام.
يعني دكتور تنصحنا دائما نصير يعني نستعين بجدول التمبريتشر دايم؟
طبعا على حسب زي ما قلت لك، على حسب السؤال، على حسب sometimes I ask you to use the table, sometimes use equations, it depends يعني it depends. مو انه بس على التمبريتشر، هو على انت you need to understand the concept behind خلينا نقول incompressible model. تمام؟ التيبلز على فكرة التيبلز كيف اوجدوا التيبلز هذه؟ They did experiments. The tables represent a lot of data, then they try to fit that data in terms of trends يعني. But they did a lot of experiments and then they put it in terms of tables. And sometimes the tables is not available all the time, so I need to do some approximations. I need to use equations. I need to use models like this in compressible model. Okay? فيعتمد على بس أهم شيء إنك تفهم الكونسبت. اوكي ما في شيء واحد قصدي اني اقول لك ايه اعتمد على هذا، لا، على حسب الكيس، على حسب الكونسبت that you need to use.
حلو يعطيك العافية.
موفقين يا شباب، طولنا عليكم.
دكتور.
Yes.
Do we have a cover حق for the homework cover page?
ما يحتاج cover page يعني إذا بتحط بس أهم شيء اسمك كذا وخلاص يعني. أو your own cover page, it's fine.
Okay. And I am stuck with problem 4 with section B. Can you help me with it? The final temperature.
Let's
For
talk
each
outside the class.
Sure. When?
دكتور